My name is Otavio Santana, and let's talk about one thing that's super interesting, the persistence layer. Nobody usually care about it, and that's a place where we have a huge nightmare. So just to know a little bit about you, how many of you are architects or senior engineers? Okay, so nice. So today, we're gonna cover something that's no super trends, so there is no buzz layer here. It's something that we call reality. And okay, let's talk about database and why we should care more about that. And why we need to care about this anyway. Talking about a little bit about history, the database has the main goal to ensure the knowledge through the humanity. We care a lot about this because there is where we keep the knowledge. And if you think on philosophy way, the database starts with temples and caves because that's where we put our first knowledge. But enough of knowledge here today. And going through the whole history of humankind, we started, yes, with the caves and then move out to libraries. And then that was enough. We need to have some efficient way to handle with a lot of information and then move to distributed data that we're living today. Talking more about IT, why do we need applications or why our application need data storage today? So we usually talk about stateless application. The question is, does it exist? Usually when we talk about this, probably this state belongs to the database. When we talk about business, we talk about data, right? We talk about the new business and of course the future of the company business. For example, I worked in a company as a consultant where it's a bank and they had a card and they did analysis of the history of the users, and based on that they decided to create a winery. And this winery became the top 3 in 3 months, basically because on that information this bank could create a winery. So the current opportunity with the data, of course the information of the bank system and things like that, and also new opportunities like this. Okay, I know that a lot of users of the black card enjoy wine, so let's launch a winery based on that profile. And of course, we know that database is super crucial. We know that we have a lot of flavors of database nowadays. For example, here, it belongs to Stack Overflow this year. As you can see, there is no a single language, as there is no a single database where enterprise are using right now. So the majority is still using SQL database, relational database. However, the flavor of NoSQL database has increased. So this, for example, in a bank, it's possible to see several NoSQL database using something that might be impossible 10 or even 10 years ago. Okay? So we have, when you compare with application and database, application has much more maturity models. So probably you know the Glory REST that covers several aspects of REST application. And we just have a few maturity models to NoSQL database, to SQL database, or even to persistence layers. With the majority here, I guess, are Java developer, right? So about paradigms, we're still using OOP combined with domain-driven design in the majority of our applications. However, when you go to relational persistence layer, we handle with SQL, NoSQL, and with NoSQL, we have key value, document, wide column, graph, time series, multimodal, and so on. So we have a huge amount of paradigms when we talk about persistence layer, and of course, database flavors. So a single organization can use several database paradigms, several flavors, several contracts, and so on. And I don't need to mention the challenge to handle with the persistence layer, right? I guess everybody here knows that better than me. Especially because when we decide to create a single application, the first thing that we usually do is define the modeling of this database, especially if you are handling with relational database. And that time, the first step of the application is where we don't have enough knowledge of the application or the product is not mature enough. Based on that, we need to do several refactoring, things like that, and that starts a nightmare because refactor some code is basically an IDE and a PR. With the database, on the other hand, is a little bit more complex because every time that we need to do any kind of refactoring in the database, rename some field, rename some table, we need also to run the migration. So it increases a little bit more the challenge of the database and the persistence layer. And of course, the product keep evolving. So we need to think also around the evolutionary data when we think about the persistence layer, right? I mean, how to upgrade the database is important, it's crucial. How to keep doing the migrations to change the product if without impact the application. As you might notice, if you create an application and need to start from scratch this application in less than 10 years, in less of 20 years, for several organizations, that means it was a failure project because the application should live at least 1 decade to achieve the success of that. So it will make sense to restart from scratch every single 3 years. And talking about persistence layer, we also have the connection and the communication between my application that has one paradigm and my database itself. For example, here, I guess everybody's familiar with relational database, where we do have our application, so you can use Java, Kotlin, Ruby, whatever. That, on this case, is object-oriented language, where I do have person and address. So, in the language layer, in the application layer, is basically link reference. As you can see, I do have a person. Each has a list of address. So basically, I do have a link of this reference, and then I can store this information in my memory. And on the other hand, inside my database, I do need to care about more aspects of this kind of thing. For example, with relational database, I have a second table to do this link. So my pointer in my database is another table to make it possible. And it's happened, and doesn't matter the NoSQL database you are handle. And that is the nightmare number one. So we do have the application, we do have the database. It doesn't matter the paradigms that we're going to use. So wide column, graph, document, key value. And the key point here is I do have paradigms that make sense to my application side where my database does not know. For example, heritage, polymorphisms, encapsulations, and types, of course. And for my application, if you're going to use SQL, I need to care about normalization process. If you're going to use something else like NoSQL, I will handle the normalization process, especially the structure inside my database. And based on that, we also need to we have another challenge. That is the mismatch mapping or the mismatch impedance between the application and also the database. Okay, Otavio, you talk about several challenges to handle with the database, the challenge to handle with the database and the application itself, and of course, how we can handle that. And the main idea is to don't reinvented the wheel. Of course, the market has and also provides several data integration patterns. I'm talking about Java here, but of course, you do have this for several languages. Because this presentation is only 50 minutes, of course, we cover only 6 integration samples here. That is driver, data mapper, data access object, active record repository, and DTO, data transfer object. And the idea here is to explain, okay, how we can use these patterns to make our life easier to integrate our application with the database itself. And before it starts, to explain more in detail of each pattern, we need to understand the proximity of each pattern is of the database or the application. As you can see here, I can have my pattern close to the database. In Java, we usually try to be oriented to OOP. That's nice. However, you have more flavors and more ways to handle with data-oriented programming, especially after Java 16 with record and features like that. So, sorry, Java 14. So we do have driver that's closer to database where you can explore more the feature around the data. I will explain quickly the difference between data-oriented programming and object-oriented programming. And we do have repository that will be more closer to the application, closer to domain, and of course far from the database. And as you might know, everything in software architecture has trade-off. We need to choose each one we're going to take, right? So again, close to the database, probably it will run more data-oriented programming, far from the database, and close to the domain, and close to the application. Talking Java right now, is more domain-centric and more oriented-centric. And everything here has a trade-off. Talking about those paradigms here, I will start with, of course, the data-oriented programming. It's a huge idea, paradigms, I will explain in 4 principles. And of course, if you want to know more, there is this amazing book here, and there are several articles in InfoQ explaining the idea of the database-oriented programming. But the idea is, okay, let's explore the data and forget about the behavior. Let's represent the data generically, focus on the data structure. The third point here is work with immutable. Please don't work with mutable with data-oriented programming. And the last one here of those principles is separating data schema from the data representation. So I want you to be focused more in the data than anything else. So if you want to know more, as I said, data-oriented programming, it's an amazing book. On the other hand, we usually go to do the opposite. So I guess everybody knows the clean code where the main idea of OOP is exactly the opposite. So expose the behavior to what? Hide data. Explore abstraction. Use layers and modules exactly to be more domain-centric, to hide the information to explore behavior. So right now we have 6 patterns, and you do have 2 paradigms. One close to the application, another one close to the database, okay? So with that idea, let's go one by one. Of course, I'm using Java here because I do some open source work in the specification, but you can use your own language. The idea keep the same. The first one that we cover today is the driver. The idea of the driver is to be closer to the database and a little bit far from the application. In some cases, it makes sense. So this is a sample of the JDBC in Java, the right connection with the database, with relational database. But of course, if you wish, you can do it pretty similar with MongoDB, with the MongoDB driver, with Cassandra, with Neo4j, with Tinkerpop and so on. So as you can see, I opened the connection. I have my statement result set, and then I could get the information from that. The structure in my result set looks like a immutable map. So I get the label, and then return for me the information from that. So I don't have a schema. I have just the data oriented. So the flexibility, looking more to the data perspective, is more flexible because I can extract whatever I want. I can do a query whatever I want. But imagine that I need to do the conversion to my domain. So it's a huge distance between your person and your data structure. So it makes sense a lot of in data migrations, data analysis, and so on. But if I need to do, for example, the conversion to my person entity, a lot of bullet plates. Bullet plates means, of course, probably of bugs. So the bad code is the code that you don't write. Okay, to reduce this distance between the data and the application, what you can do is, of course, explore more the idea of the mapper. What is the main goal of the mapper? Is to do that conversion. So I have my structure as result set, or my Fluent document using MongoDB, for example, or result query from Cassandra and so on. And then I can do the conversion centralized in a single place. The advantage of that is, of course, I can centralize in a single place. And I can use both. With Java, we can use, for example, annotation. You might be super familiar with that. So this sample here is with JPA. So I have the annotation to entity to define. This one here is the ID, and then the name, the birthday, the address, and so on. And we also do have the JDBC template from Spring, where if you wish, you can do it manually. So I have my person rule mapper that implements the rule mapper, and then give this result set. I'm capable to retrieve that information and then convert to my class. So I centralize my mapper, I centralize my responsibility, or I delegate it to any kind of framework. However, when we do that, we are facing the impedance mismatch, as I said. And again, it has trade-off. So you probably are familiar with the issue of query n+1, where accidentally you are doing more query than we wish. So it's starting because this kind of thing, the impedance between paradigms. So sometimes do the mapper is not enough. We also want to centralize the application or data operation in a single layer. And based on that, you can also, if you wish, centralize the data operation in the layer to make sure that nobody will know or handle anything else than the information. So we're still facing the impedance mismatch. It's impossible to escape right now because it's involving two paradigms. But utilities, you right now at least have one centralized layer to handle with the database. Here is a sample. So I do have the person DAO, where I have a couple of operation with my database. So I'm capable to insert, I'm capable to delete, I'm capable to update, and of course, return all information. Moving far from the database, we also have the active record. Super familiar, who is familiar with Ruby? And increase the popularity with Quarkus and Panache right now, where your entity has the superpower to handle the domain and also the database operation. So the good point of that is you have your entity, and your entity is capable to persist, to list out, to find by ID, and things like that. However, what you're facing here, we are breaking the solid principle. So right now, my domain, my entity, need to do the database operation and also the NT operation itself. So, of course, in the majority of the time, especially when you handle with a super complex domain, it does not make sense, okay? And the farthest that we cover today is the repository. I guess everybody here is super familiar with DDD, the domain-driven design. This one here is the super far that we're gonna cover today around the application, where I do have my NT, I do have my mapper, and as you can see here, I do have my repository. The idea of repository is to be a collection of an NT. And as you can see here, instead of insert, update, delete, I do have the save methods. What it does mean for me as a user, I have no idea. It might be inserting, it might be updating based on the condition. For example, if I do have an ID and I did not find this NT, I will insert. Otherwise, I will update. So it's super domain oriented. However, sometimes we did a mistake to forget about the database. And of course, there is huge consequence doing that. So, as I said, everything has a trade-off. One discussion that I usually have around the database integration, especially the data mapping, is around, okay, Otavio, should I have repository or should I do everything by my own? If you decide to do everything by your own, your clients you become super fat because they have several obligations, they have several duties. And as I said, more code, more responsibility, more probably of bugs, more tests, and of course, more nightmares. And on the other hand, if you do the divide and conquer, as you can see here, you do have your client, your repository, your DAO, your mapper, and finally your repository. So your client just know a little bit of the responsibility. Sometimes your client, you know only the domain because you create several layers to put it far from the database. And as I mentioned, the key is, of course, trade-off because every time that you put layer inside the application, you have the power to do abstractions. For example, here, I do have my NT, I do have my repository, and I could have several adapters to handle with different NoSQL and SQL database. For example, give a person. I have my person as NT, I have my repository, and I can do have a modeling to each database target. So I can do a perfect modeling using normalization to SQL. I can do the normalization to wide column, such as Cassandra, and I can do a cache-oriented using key on another one. So my NT, you'll be super protected from my database modeling because I do have adapters. But as you can see, I'm putting layers and layers and layers and layers. And of course, it might be a nightmare to handle. And as you might be familiar, the majority of the application right now is exporting this data as REST API, so JSON. So remember, we don't have only adapter to the database, but also need to have adapter to the input as well. So in that case, mostly of the time we're gonna use DTO or data transfer object, where we do have our NT, our resource. Sometimes people use controller, it's fine. And finally my DTO to separate my entity from the data that I want to export, that I want to expose. And that's the goal point here. So, okay, you can put several modules, you can put several layers, but more layers also mean nightmare. You are able to, of course, separate, you of course aggregate, but at the end, layers is more work to do. And even with Java framework, of course, the majority of you here might use any kind of Java framework, especially because it does not make sense to do it by hand. One mistake that I saw a long time ago was, okay, Otavio, I don't want to use Hibernate or any kind of DPA implementation because I want to do it by my bare hand. And then I reply with, okay, so you're saying that 20 years of an open source project with the more brilliant people is not enough to you decide to reinvent the wheel? Please tell me why. And usually they claim about the performance, the optimization, and sometimes they don't understand that we also need to handle the time to create this kind of thing, the time to maintain this kind of thing, and of course the time to optimize this kind of thing. So usually I recommend to handle with any kind of framework and don't do it by your bare hand. Especially because doing this approach, you're gonna reduce a lot of boilerplate. You're gonna enhance the communication, especially because we are talking about some framework that has over 10 years of market. And as I said, with the persistence layer, we are talking more about the polyglot persistence. This particular behavior matters a lot. It doesn't matter if you're gonna use SQL or NoSQL. You want to optimize this kind of thing. So if you're gonna use Cassandra, of course, I want to define the consistency level. I want to run and use Cassandra query language. If you're gonna use MongoDB, I want to use geolocalization. So those particular behaviors in SQL and NoSQL matters to us, especially when we need to define this as a software architecture. And right now we understood the patterns around the persistence layer, the definition around this distance between, okay, this one here is too close to the application, that I need to face some trade-offs like impedance, or this one here is super close to the database where I'm capable of exploring the domain, the data domain oriented, but I also have trade-off. And right now, please use frameworks to avoid any kind of nightmare. And when we talk about frameworks, we have several categories and several types. To make it easier, I put here this kind of thing to define the framework based on 4 categories or 4 types. So when you decide to use any kind of SQL or NoSQL framework, you are able to analyze those in 4 categories. The first one is the legibility of the framework, where you are able to do on the declarative way, for example, with Spring Data, where you are able to say, mynt save, and he will find out if you're gonna need to insert or update, or the imperative way, where you need to define step by step of this application. The proximity of the application from the domain or application or the database. For example, we do have Jock. Jock is an amazing framework where you are able to do any query super close to the database. And we also have the Jakarta data where you're able to run queries around the domain. The usability of the framework. So with a single API, a single annotation, how much NoSQL or SQL database I'm capable of use. The agnostic one is basically one API to many database persistence. For example, Jakarta data, Eclipse NoSQL in Spring Data. And we also have the specific one, for example, Neo4j has the Neo4j, Cassandra has a data stacks driver mapper, and so on. And the last term that we should pay attention, of course, in the time of microservice is the executability of this application. Okay, is this application using reflection, where I get more flexibility on runtime, but the word map is more difficult because it needs to read the whole information on runtime, in reflection, costs a lot of memory to read, to understand, and process. Or I'm going to use reflectionless solution. So I will read this annotation on the build time. So it will save me a lot of word map time. It will save me a lot of memory because the information is already there. However, I lost my flexibility on runtime that I do have with reflection. Each one of those categories has trade-offs, as you can imagine. But at the end, when you do have the persistence layer, we want to achieve just 3 goals. The first one, of course, is the business. We want to achieve result with the business perspective. So we want to get there. Exploring, for example, the domain-driven design. Exploring more the oriented. Make the API safer. At the same time, we also want to have isolation. Why? Because it doesn't make sense to my user receive a Cassandra exception when they use the application. We need to handle these exceptions to make sure that the user, you got a readable and understandable exception error. And the last one, of course, performance. Because it doesn't matter the database that I want to use, I want to take the maximum activity of this database exploring the performance. So if I want to use SQL, I want to explore the index, secondary index, B3, hash tree, and so on. If I'm going to use Cassandra, I want to explore consistency level, partitioning, and so on. If I want to use Redis, and so on. So I usually want to have those 3 achievements of my goals when you talk about architecturing application layer. So business, isolation, and of course performance. And as I mentioned before, those 3 rules are based on trade-offs. There is this amazing book here, The Fundamentals of Software Architecture by Neil Ford, that we do have two laws to learn and adapt. The first one is everything in software architecture is a trade-off. This one here is impossible to escape. So, as I mentioned before, if you go to database, I have one trade-off, another database is one trade-off. It doesn't matter wherever you go, it provides trade-off. If you're going to take a decision that we're not able to measure the trade-off, probably you are not the best person to take that decision. So if I am only capable to take advantage of this approach, I need to think twice because there are points that I will lose because of that. And the second one is the why. The reason that we're doing that is more important than the how. The how doesn't matter sometimes because I know what I want to achieve. So if are we going to use SQL, NoSQL, multimodal, whatever, that means the why is super more important than how. And based on that, it increased the philosophy of the polyglot persistence. Because every case, you might use the better database that fits with this point, with this issue. Especially right now where we are living the microservice age, where I don't need to have one single database. So essentially, I do have one microservice with one database and so on. So based on that, if I'm going to do a recommendation engine fraud detection, I can use the best database to fit on that situation. If I'm going to use some session management, I can use the best database to fit on that, in that point, and so on. The idea of the polyglot persistence is not to duplicate the relational database. Come on, it has over 50 years of experience, of tools, of knowledge around SQL database. It's impossible to don't use that. It's super mature. The idea of the polyglot persistence is, okay, right now I do have more flavors to explore, if without forget what I do have. I will explore quickly here the models that is NoSQL, for example, the key value, where the main idea is to have the key and the value. I guess the majority here is Java developers, right? So the idea here is to have like a map or a dictionary of any language where I do have my key to return my information super quickly, and the value, the information itself, like a blob. So with this key value, I do have several cases that am I considering to use when I decide to go to key value, for example, Redis. So you can use Redis for caching, of course. You can speed up in retrieving some information super crucial for your application. Session management. As I mentioned, okay, my application is stateless, but I should need to know about my user. Where this information to go? The session management using Redis, for example, real-time analytics and pub-sub messaging. So you can use event-driven architecture with this kind of NoSQL database. Of course, the good point of Redis or any key value is I can simplify the schema. So it's basically oriented by key. I can use keys to everything. I can do batch operation because, as I said, it's basically a key. I don't need to handle with update and inserts. The majority of this key value database is based on append model. What does that mean? Is upsert. So if the information is there, it will update. If the information is not there, it will insert. And what you might realize, it doesn't make sense to have complex join, especially because key value does not have support to any kind of thing like that. Beware of over normalization. The database does not fit this way. Take care of the value, the size of the value. Some database provides index. Please be careful of that. This is a sample of the scalable architecture with Redis, where I do have the key based on the hash, and this hash have some partitioning. And as you can see, I'm using here the key value, where the idea is based on the key, I will go to some cluster. And if I will read, I will use my replica. If I will write, I will use my master. And if I will write, I have the one way to make super consistent, holding the replica to read something else. And that is it. So that is the idea of distributed architecture with Redis. Then wide column structure. As you can see, it's pretty similar to key value, where I do have my key, row key, my column. The difference right now is instead of have a huge blob as value, I can take it a small piece such as columns. So I do have my column dirty, column color, and so on. So the idea here is instead of I have a unique value, I have a small piece of values called column. Of course, the most famous one is Cassandra as word column. Here, I do have some case that you might considering to use if you go to explore Cassandra with wide column. So online retail, social media analytics, real-time analytics, login, monitoring, event-driven architecture. So we're able to put the event there and return. You're also capable to define TTL, or time to live of those objects, and so on. The do and don'ts of Cassandra or any wide column database, of course, they normalize when necessary. Indeed, normalize is your best friend. Design for queries. So, okay, I want to return my user by ID that needs that information. So, create that query to find by ID with the information that we need. Utilize secondary index, but as don't, pay attention of the normalization, because the normalization also means a lot of work, and pay attention with a lot of secondary indexes, because it's not super optimized as the primary index. Here's a sample of Cassandra cluster. As you can see, this approach is more masterless scheme, where I do have my clients that might use to each request a different node, okay? So the sample here, I will do a request, you will take the 10, but as I said, I can use 11, 12, and so on. It will take a request based on the consistency level, take the information that it needs, take the most updated based on the clock vector, and then return to the client. So the client do a request, have one seed or node to organize the request, do the question to another node, then centralize, and then return to the client. And then it will run the read repair. If some of those nodes had any of duplicated information, it will read repair asynchronously. So it will update asynchronously after return the information. Then we do have the document structure that looks like XML or JSON file. Of NoSQL database, this one here is capable to do queries than the ID. So as I mentioned, the key value, in majority, the best approach is exploring the ID, wide column as well. With document, on the other hand, given this structure, I'm capable to do the query by ID, by name, by dirty, by symlinks, and so on. So you do have more power to do queries. Some user cases with MongoDB, the most popular NoSQL document, so content management, catalog management, mobile application, especially because the majority of the application are using JSON. So you can receive JSON, store JSON, and then return JSON if without doing any kind of translation or mapper, if you wish. And social media as well. You can explore embedded documents instead of doing joins, especially because MongoDB has no support to joins. So you can use index. Sometimes it makes sense to do any kind of normalization logical. So you can do queries, so you have a document with ID, and then have another document that we can put some IDs to find the information there. But of course, be aware of that. You should not use it a lot because the normalization is still your friend. Pay attention of embedding or using subdocuments a lot. And as usual, pay attention with a lot of index. It's a sample of distributed MongoDB, so you are capable to read and write. We do have the primary to write information. It's a master lazy schema where my primary node is responsible to write and update the secondary nodes. And when I need to read, I will take the information from my replicas. If I have a huge amount of data, of course, I'm capable to do sharding. And to do it, I have my router that knows, okay, based on this, so on these hands, it should go to shard A, shard B, or shard C. The last one that we cover today is graph structure. So I'm capable to do more queries even deeper than SQL database because right now my relationship has directions. So as you can see here, I do have Apollos, Ares, and Kratos. And I do have direction of my entities. So Apollo killed Kratos. Apollo was killed by Kratos, and Kratos killed Apollo. And it makes sense a lot, especially when you do fraud detection or social media recommendation. For example, just because I know Neymar or Cristiano Ronaldo, it doesn't mean that they know me, right? It's a one direction. Just because I know one famous person, like Elias, it doesn't mean that he knows me, right? So one direction relationship. It makes sense in several things. So the good point of Neo4j in any kind of graph database is you can embrace the relationship-driven design. So you can explore directions of this relationship. You can put properties. So I can say that I know Elias when, how, and how often I see him on this property. I don't have to need another entity to put that information. So those are the case. So social networks, recommendation engines, sorry, knowledge graphs, fraud detections, and network analysis. Here's a sample of working with replica and distributed database. Of course, we still have a leader to handle the write operation, and we also have the read replica. So basically, if I will write something, I'm going to use the leader. If I'm going to read something, I can use the replica to make it possible. And based on that, okay, we covered several NoSQL databases today. We need to understand that, and on the other hand, I can have a huge scalability, but this means also less flexibility to do queries. What do I mean about queries? Flexibility is the possibility to do queries better than the ID. So if I want to, for example, I do have my person entity with ID, name, birthday, things like that. With key value, I'm capable to do super scalable instance, super quickly instance. However, I'm not capable to do something else and find information by the ID. So I'm capable to do a query by name. If I do, I need to do a linear search. And that, of course, is not optimized. On the other hand, I do have a column that's pretty similar, but I'm capable to do secondary index. And then I do have time series. Finally, I do have documents. With documents, I'm capable to do queries by the ID and, of course, another fields like name, birthday, and so on. However, it's not super scalable like a key value database. And the last one is a graph, where I have a super power to do queries, to do relationships, to do direction of relationships, to do queries in a relationship that has properties, but is not scalable as the key value. So everything goes around trade-offs. It's impossible to escape. Based on that, to pay attention, we also need to take and pay attention on the definition of replica of our database. So the massless, where every instance is capable to read and write information, where the advantage is I don't overload one instance. So on this case here, I have 4 instances. All those instances is capable of read and write. However, sometimes I can read information that's not super updated because I can write in the time 1 in the instance A and read in the time 2 in the instance C, for example. But this time was not able to the instance share the updated data. And on the other hand, we do have the replication of master, slave, or leader follow, where one node is responsible to write information, hold, share the information synchronously to the replicas, where I guarantee a super strong consistency. However, if I do a lot of writing process, it might overload the master. So it might be a nightmare. And there we go. We are facing the capturing around the data replication. So, of course, the idea here is not to cover everything around the persistence layer. It's just to give you the overview around the data persistence layer, why it's important, why we do have patterns, the distance between patterns, and so on. But we do have a huge amount of this, so we have transactions, database metrics, cache, level of cache, data manipulation problems, framework problems, connection pool problems, data storage problems, we have cloud problems. And the main idea here, the main topic here is to give you the overview why it super matters to us as software engineer, and why we need to understand better the idea of the polyglot persistence, and why we also need to explore more something else than SQL database. So, to explain more, I wrote this book here where the main goal is to explain more the idea of the persistence layer for Java applications. So, the idea of explore the persistence, the idea of NoSQL database, SQL database, frameworks, how to use with Quarkus, microprofile, and so on. So that's all for today. Hopefully you enjoy. And before you go, I do have socks and stickers for you. That's all. Thank you.